For exam 1, MAC1105. So part A says state the quadratic formula, super easy. X equals negative b plus or minus square root b squared minus 4ac all over 2a, right? Okay, easy, especially since the quadratic formula is usually not given to you and you have to state it yourself. Okay, part B, state the standard equation form of a circle. So we know that we use the complete the square method to find the center of the circle and the radius, right? So this is the formula, again, not given to you. You should know that if you are able to write this as 2 terms squared plus 2 terms squared, then you'll be able to get all the parts you need to draw the circle, and then you can answer questions like what is the domain, what is the range, right? Okay, so remember that the center is h comma k. So it's the number that you're subtracting from x and the number you're subtracting from y. And then of course, radius is whatever number's here, square rooted, right? Because if radius squared is some number, then the opposite of squaring is square rooting. So I'm gonna go ahead and square root and get my radius, right? And of course it's just the positive. Remember, square root is a plus or minus, right? The positive answer and the negative answer. But here, we're only looking at positive because of course radius has to be positive, right? It's a distance from 0 to create the circle. Okay, so now let's get into linear equations. This is a review of a lot of topics. Okay, part C, solve for x if you have a fraction. Right here. Okay, so first we want to solve for x, right? So the first thing I'm going to do is, of course, get my numbers together using opposite operations. Okay, and this 2 is being divided by this x minus 2, which has the x that I'm trying to solve. So you're going to go ahead and cancel the denominator by multiplying by x minus 2, right? That's just the number. Great, so this is 2 equals, and then this 2 I'm going to distribute. And then it's just a normal equation, right? At this point, we're at the end of the semester, so what was once difficult for you shouldn't be as difficult anymore because you've been practicing these skills for a long time now. Okay, so x equals 3, you could plug back in to check. And of course, you want to do this algebraically to prove that you know how to isolate a variable, distribute, do opposite operations, right? That's what we do to find the unknown value. Okay, next one. Again, with all of these, you have to look at it and you have to see, okay, what do I have to do, right? You have to solve for x, but you're going to have to do different things, different steps. It's not always the same exact step every time, right? Which is why you have to understand what you're doing and why you're doing it, right? So we're trying to solve for x. So we're going to distribute that 3, distribute that 2, right? And then we'll see what happens after that. But usually you put your like terms together. All right, here I could do negative 12 plus 17, that's 5. And then of course solve for x. This is a normal one-step equation. All my x's are on the same side. What's x? Of course, x has to be 10 minus 5, which is 5. Again, you can plug it in, you can double check. This is all about putting like terms together and canceling to have only the variable on one side. And then from there, it's a normal equation. All right, this one's fun. Solve for x. All right, so we have some denominators that are different. And so most of the time you see, okay, is there this common multiple that I can multiply by it in order to make these all whole numbers if you don't want to work with fractions, which most individuals prefer whole numbers. So think about it. What is the least common multiple of 7, 2, and 14? What is the least common multiple? That means look at the multiples, the timetables of 2, 7, and 14. When do they all, when we look at the timetables, when do we get the smallest number that they all have in common? Well, of course, that would be 14, right? 2 times 7 is 14, 7 times 2, 14, 14 times 1 is 14. Right, so the 14 is the smallest number that they all have in common in the timetables of 2, 7, and 14. Right, that means that if I multiply everything, not just one term or two terms, but all the terms by 14, then that means that this is gonna divide evenly and nicely, and I'm gonna be able to solve for x. Okay, so think about it here. This 14 is being distributed, so be careful. So it's gonna be, I could do this, 14 times the 6x divided by 7, and then distribute that 14 as well. And over here, this 14 is distributed, so that means it's gonna cancel with this 14, just leave me with x, and then it's gonna be negative 9 over 2 times 14. Right? So now is when we have to simplify, and all these are skills that we can hone if we don't already have with fractions. Okay, so 7 and 14 are both divisible by 7, so 7 divided by 1 is 1. Sorry, 7 divided by 7 is 1, and 14 divided by 7 is 2. So that's just 2 times x. Sorry, 2 times 6x, which is 12x. And then over here, 2 and 14 are both divisible by 2, so this becomes a 1, this becomes a 7. And what is negative 9 times 7? Negative 63. Alright, again, what are we doing? We're solving for x, so keep getting your x's together. So we're going to subtract x. So this is 11x. Wait, give me a second. Yeah, before I even do that, just notice both of these have x's in it, so let's join our like terms first. So what's 12x minus 14x? Negative 2x. Okay, and then get your like terms together. So now subtract the x, That's negative 3x equals negative 63. What's the opposite of multiplying x by negative 3? Dividing by negative 3. And of course, a negative divided by negative is a positive, so it's just x equals 21. Again, plug in if you need to, or want to, and you should get 21. Works. The left side equals the right hand side. Alright, so that was part C. Now let's look at part D. Okay, so now we have an absolute value. Okay, remember that absolute value is the distance from the number in the absolute value to 0 on the number line. So we're going to have two answers, but before we're going to do this, I can't just disregard the absolute value and treat it like a parentheses and use this 3 to distribute. That's not correct. Okay, remember that we need to figure out what the absolute value equals to get our two answers. So first you need to isolate your absolute value. Right, so what is the opposite of multiplying the absolute value of 2x minus 7 with 3? Dividing by 3, so that should be your first step. So this is the absolute value of 2x minus 7 equals 7, right? 21 divided by 3 is 7. So now we have our two possibilities. We have when this number, whatever this number is, equals 7, because the absolute value of 7 is 7 units away from 0. Or when the inside number, 2x minus 7, equals negative 7, because again, the absolute value of negative 7 is 7 units away from 0 on the left side of the number line, right? So now just solve for x, and the rest is easy. So these are your two cases that you need to set up. You want to be able to solve for both. Okay. So x can equal 7 or x can equal 0. Alright, part E, inequalities. Now we have an absolute value inequality. So again, two cases, but let's check it out. Okay, so the instructions are solve, plot on a number line, and write the solution set in interval notation. Okay, so let's solve for x. So just like before, I'm isolating my absolute value. Okay, so always check that this makes sense. Okay, can an absolute value, which is going to give us either 0 or a positive number as an answer, be greater than 15? Yes. Okay, if this was less than a negative, well, a positive number can never be less than a negative, so we would say no solution. In this case, yes, it's definitely possible. So now I'm going to have my two answers. I'm going to have when this number 2x minus 3 is greater than 15 and solve. Right, this is what we did the second day of class. Or when this number, let's say this number is negative, right? So this number is negative. Okay, remember that when we absolute value it, it's basically saying, hey, how many units away from 0 is this number, right? Well, if it's a negative number, then it's still going to be a positive amount of distance away from this number, 2x minus 3. Right? Let's say this was, I don't know, 11. What's the absolute value of negative 11? 11, because it's 11 units away from 0 on the left of the number line. So same concept. So let's say that this number is negative. When we absolute value it, it's going to still be the 2x minus 3, right, that we need. And we want to make sure this is greater than 15 as well. Okay, so this is the kind of the part that sometimes we jump as we get better and more used to it. This is just to prove to you why we do what we do, which is we divide by that negative in front that it could possibly have. Okay, so that's just going to leave us with 2x minus 3. And what is 15 divided by negative 1? Negative 15. But what do you do when you divide or multiply by a negative? You have to flip the sign, right? So this is why many times when we get to this point, we have two cases where that number, inside number, is greater than 15, or when that inside number is less than the opposite sign of 15. Which is negative 15, right? And then from there, you just solve. That means x has to be greater than 9, or 2x is less than negative 12, or x is less than negative 6. Okay, this is an or statement, so either this or that. Okay, so we're not done yet. We have to draw this on the number line. Okay, so let's use intervals of 3, considering they're both in the 3 timetables. So 0, 3, 6, 9, negative 3, negative 6, negative 9, negative 12. Okay, so x is greater than 9. Okay, so that's open circle because it has to be greater than. It cannot equal 9. It could be anything greater than 9 or bigger than 9. So that would be numbers shaded to the right, like 10, 11, 12. This is x is less than negative 6, so open circle at negative 6. It can't equal negative 6, but anything less than it or smaller than it. So it's going to be things shaded to the left, right? Okay, great. Now how do I write this in interval notation? Well, once you draw it on the number line, it's a lot easier to see. So look at all the potential solutions, right? It's a lot of numbers that can satisfy this instead of it being just 2 answers. Okay, it's a lot of answers. So here we have, this is all the negative numbers. So this is from negative infinity to negative 6, open circle, union from 9 to infinity, right? And so at this point, we've done this enough times that now we understand. But remember that putting it on the number line is always going to help you be able to write in interval notation. If you just try to go from here, you can mess up. Okay. All right, so the next one is a compound inequality, right? Which means that we have still 2 absolute value inequalities, but we're solving them simultaneously. So let's check it out. Okay, so here we're trying to solve for x, of course. Oh, it's just a regular, it's a compound inequality, but it's not absolute. Okay, so let's subtract 6. Let's get our x alone. Whatever you do to one side, you do to the other 2 sides because there are 2 inequalities happening at the same time. Right, so it's going to be 3x is less than or equal to 12 on the right or greater than negative 3 on the left. Okay, remember that we need to get x alone, so continue to do opposite operations. And remember, when you divide by a positive number, nothing changes. It's only when you multiply or divide by a negative number that you would flip the sign. So this is going to be x is, when you read it from, you look at the variable and you read it to the left, right? So if I read it to the left, I'm reading that x is greater than -1, right? X is greater than -1. The alligator mouth eats the x, right? So it has to keep eating it. This is the one that maybe gives you more difficulty with reading. And then of course, when you look to the right, that one's a lot clearer to see. It's just also x has to be less than or equal to 4, right? So you can leave it like this for your solution, right? Unless you're told to write it in interval notation, and we are. So it says, how do I write this in interval notation? Well, maybe it'll help us to graph it on a number line. Okay, so let's see. So this is 1 and 4. So let's use intervals of 1 to get to 1 and 4. Make this longer. Okay, so here it says x is greater than -1. So that means it's going to be open circle at -1. It cannot be -1, but it could be anything greater than -1. So that would be numbers to the right, right? 0, 1, 2, those are all greater. And at the same time, x has to be less than or equal to 4. So now we get to close the circle at 4. It could equal 4, it could be any value less than 4. So that means that these numbers within this region are our solutions, right? So now we can write that. So let's write that with a parentheses for open circle, starts at -1 and goes all the way to 4 with the bracket at 4 because 4 is part of the solution set. Okay, so that's how we solve a compound inequality, and we read the inequalities. Remember, there's two inequalities happening as an OR statement. When we write it on the solution, on the graph, we plot it on the number line, then we're able to write this in interval notation. Okay, so these are our solutions, or solution set, and interval notation. Okay. And again, you can go back to the video and watch it again or pause if you need more time. Okay, time for part F. We have some imaginary numbers, right? Square roots, do you know how to simplify them? If not, it's a good time to review. Are there any pairs? Are there any couples? Are there any singles? So let's make sure you know how to do that. So for the first part, it says, find the product and write the result in standard form. Okay, remember product means multiplication. All right, so what do we have here? This is definitely distribution. Right? This is -10 times 3, which is -30, and I times I is I squared. Okay, great. The next part, distribute, keep distributing. What is -10i times -4? That's +40i. And remember that I squared is -1, so you do have to plug in, because you're trying to simplify, and write this in standard form. Remember, standard form means the number and then the imaginary number after that. Okay, once you plug in, the rest is easy, because what is -30 times -1? 30 plus 40i. This is in standard form. Okay. All right, next one is simplify square root of -300. Now we know that this is a negative number, so that means that it is imaginary. So this is the same as -1 times 300. And you can even split it. This is the same as the square root of -1 times the square root of 300, right? Both of the numbers are in square roots, so I can break it up like this. Now, what is the square root of -1? I, right? So now we just have to worry about breaking down 300. And again, if we've talked about, there's many ways to do this, but I can break this down as 103. Let's say you like to break it down all the way. Let's just do it like that. I'm doing 103, 3 is prime, so I leave it. 100 is 10 times 10, 10 is 5 times 2, so here we have a couple of 2, so you write 1, 2 on the outside, a couple of 5, circle the couple, one number per couple, okay, and the little 3 is sad and waiting until his time has come to have a partner. So he is to stay in the house, right? So then what's the final answer? It would be 5 times 2, which is 10, don't forget the I for imaginary, and then the square root of 3. Some people like to write the I at the end after the square root. That's fine, but just make sure that the I is not inside of the square root. Okay. Next, we have we have to divide and express the result in standard form. So we have a fraction. Okay, so how do we do that? We're trying to divide and express the result in standard form. Well, we have I, so if we can somehow have I squared, then I squared is -1, and we can have a whole number and make this nice, pretty, simplified. Right, so how do we do that? We multiply by the conjugate. Remember, the conjugate is the same as the denominator, but just opposite sign in the middle. So the conjugate of this denominator would be 7 plus 6i. But of course, whatever you do to the bottom, you do to the top. And now multiply it out. Okay, so on the bottom we have FOIL. This is why it's good to review everything, because as we continue, we're like, oh, okay, this wasn't as hard as I thought it was. It's just I needed to review FOIL, or I need to review factoring, right? So you can assess yourself and see maybe if there's anything you need to practice. Okay, so for FOIL, 7 times 7 is 49. 7 times 6i is positive 42i. That's the outer. And the inner is a negative 42i. And the last would be negative 6i times positive 6i, which is negative 36i squared. Okay, and this is nice because the i's cancel, and like we said, we know what I squared is. I squared is -1. So just plug in -1 for I squared and solve. So it's negative 36 times -1, 36. And then add 49. So just do it on the side. 85. Okay, so we got 85 for the denominator once we simplified. Okay, and now let's look at the numerator. So the numerator is just 8i times these two terms. But since there's more than one term, that means there's distribution. So what is 8i times 7? 56i. And what is 8i times 6i? Positive 6i is positive 48i squared. Okay, so almost done. Now we know what I squared is. I squared is -1. So you have to multiply 48 by -1. Okay, now I have to write it in standard form, which means I put the number first and then put the imaginary in the back. So we know that this 48 times -1 is -48. And then put the 56i, the imaginary, in the back. And of course, they're both divided by 85. So this is our final answer. Okay. Okay, one more before we factor. Now we have the square root method. Square root method is really nice when there is a quadratic function, but we don't have an inside term. We get to use the awesome square root method to solve for x. Again, what do I want? I want x. This x plus 7 is squared. I could FOIL it out, multiply by the 3, but it's kind of making more work than necessary. Remember, square root method is a simple method to make things faster and to be able to solve for x. So instead, let me see if I can isolate this x plus 7 squared, because if I do, then I can just square root and get rid of that power of 2, right? So let's see if we can get this alone. So first let me subtract the 11, get this as nice as possible. Okay, we have a 3 in front, right? So remember, I cannot distribute this 3. I can't do 3 times x and 3 times 7 and then just forget the fact that there is a power of 2. No, I need to instead isolate him. So what is the opposite of multiplying x plus 7 squared with 3? Dividing by 3, right? So you should divide by 3 at that point, and then you get that x plus 7 squared equals 16. All right, so almost done. Opposite of squaring is square rooting. Don't forget, when you square root a number, you get in the positive and negative answer. So that's x plus 7 equals plus or minus 4. Okay, you don't want to miss a solution. Square roots give 2 answers, positive and negative, unless it's specified in the domain that we don't want negatives. Okay. All right, so x plus 7 equals 4. 4 x plus 7 equals -4. Now just solve for x. Okay, so x equals -3 or x equals -5. Those are our two answers. Again, you can plug in and check. Alright. Next is our favorite. We're going to factor. We have to be very careful with factoring. We've reviewed with the warm-up questions. Okay, remember that it's not just F and L from FOIL needing to work out, but the outer and the inner definitely needs to work out for the inside term. Okay, so for number H, it says factor. Solve by factoring. So don't just factor, but solve as well. Solve for x. Erase this top one. Okay, so here we go. So we have two parentheses. Let's split up x squared, x and x. Look at the factors of 24. It's either 1 and 24, 2 and 12, 3 and 8, 4 and 6. But I have to be super careful because this sign is positive, which means that both of these numbers need to be positive or they both have to be negative, because remember at the end we're going to multiply these numbers. Okay, so I'm going to make both of them negative because I see that we're trying to get to a -10x. So we're going to want a negative number. So which of these will give me -10x? Only this. -4 minus 6 will be the only ones that can do that outer and inner that I need. Okay, when I set this equal to 0 and solve, you just get that x minus 4 equals 0 or x minus 6 equals 0. Of course, do opposite operations and get your x. Okay, now let's look at another one. Okay, remember, I also want to see if these numbers are big or seem big to you. Maybe there's a GCF that can help me. I can factor out a GCF perhaps, and then the rest might be easy for me to factor. Okay, or you could just factor straight from here. But I can see that 3, 12, and 63 are all divisible by 3. So if I take out a 3, what is left over? Well, divide each term by 3 and see what's left, because I took it out, right? So I'm factoring it out. Okay, so that leaves me with x squared plus 4x minus 21. This is going to be easier for me to factor. Right? Why is it easier? Because I can simply split x squared as x and x, and then I just have to worry about the factors of 21. Okay, so I can either use 1 and 21, well actually, or 7 times 3, right? That's it. Now, because it's negative, that means that one of these has to be positive numbers and the other one has to be a negative, right? So I'm just gonna make the second one negative, and if it doesn't work, I can just switch signs. And now which of these is gonna give me 4x? The 7 minus 3. Okay, awesome. So I did this correctly, outer and inner work out, set this equal to 0 and solve. Now, does this 3 really do anything? No, because when I divide by 3, I'm just left with the parentheses. And of course, 0 divided by anything is 0. So now I just have my two parentheses. I know how to solve this. This is two cases, either x plus 1 equals 0 or x minus 3 equals 0. Now I just solve for x. Okay, so that's it for factoring. Alright, so the next one we have quadratic formula. So again, you need to know the right formula, otherwise everything can get ruined. Alright, so here I have x squared minus 6x minus 4 equals 0, but I'm told to use a quadratic formula, not to factor. And even if I did factor, it wouldn't work. Okay, so I'm gonna determine a, b, and c from the quadratic function. So a is the number in front of x squared, that's 1. B is -6, and c is -4. So now all I have to do is plug in. Remember that this function, quadratic function, needs to be set equal to 0 in order to even use a quadratic function. Alright, so that's why when we're looking for x-intercepts, what do? We let y equals 0. In other words, we're letting the function f of x equals 0. And then we use the quadratic, right? First step, set it equal to 0. Second step, use quadratic, right? So now just plug in. This is negative times a negative 6 plus or minus square root b squared, put b in parentheses, minus 4ac all over 2a, right? So that means that this is just positive 6. And in the square root, what do we have? Remember that a negative number squared is always positive, right? So what is negative 6 squared? In other words, what is negative 6 times negative 6? That's 36. Okay, so this is 36. And then we have a negative 4 times 1 times another negative 4. So that's positive 16. Okay, so in the square root, we have 6 plus or minus the square root of 52 when we add 36 and 16 all over 2. Now with this is not, you're not supposed to actually get a decimal answer with the calculator. Instead, you're going to simplify square roots, which is why we learned that in lesson 6, right? So we're going to, I'm going to erase this to have space. Let's make sure we know how to simplify square roots. So let's simplify the square root of 52 in order to make this pretty. Okay, so 4 times 13 is 52. If you play with cards, a deck of cards has 52 cards in it, which is 13 numbers with 4 times, right? The diamond, yeah, you know. Okay, so let's do 4 times 13, and then of course the 4 is composite, so I can break it as 2 and 2. So do we have a pair? Yes, we have a pair of 2, so the 2 comes out, and this 13 is single, waiting for his partner, so he stays in the house, okay? So this means that down here, this is 6 plus or minus 2 square root of 13 all over 2. And then, of course, be very careful. This 2 is trying to divide these two numbers, the whole numbers, not the square root. You could not divide a square root by a number that is not in a square root, okay? They're not like terms. So this is 6 divided by 2, if possible, which it is, that's just 3, plus or minus 2 square root of 13 divided by 2. That's just the square root of 13. Okay, so that's your answer. That is your x-intercepts, but in this case, we hadn't learned x-intercepts at this point in the beginning of the course. So this was just the solutions for x. Later on, we actually used it to graph, to analyze a function, etc. Right, so building blocks. Alright, next one is our favorite, complete the square. Again, in math, there are different ways to solve. So there are 2 ways to complete the square, but there's an easier method that will help you if you don't want to kind of guess that extra number that you're trying to add or subtract to make this happen. Okay, so what do I mean by that? So first, take a look. First, this works with quadratic functions. So this is set equal to 0, and they told me to solve for x, or y this time, solve for y by using complete the square. This is important. This is the same method we use for circles when we're trying to find the center and the radius of a circle. Okay, so what do? So we always put the number on the right hand side. So what's the opposite of subtracting 12? Adding 12. So this is y squared minus 7y equals 12. Okay, and now we have to try to complete the square. So what do? Remember, we're getting our b, which is the number in front of the variable. We're dividing it by 2. And that's what we're using for parentheses. So this is going to be y minus 7 over 2, right? So b is negative 7 divided by 2. And that's what we're using to complete the square. Okay, so we've done this before. If you were to expand this out and do FOIL, you're going to get the inside term back, right? This is why we even do b over 2. But you're also adding the L in FOIL, right, for last. So then, in other words, if you were to expand this and check your work, in other words, when we do the L in FOIL, we're going to multiply negative 7 over 2 with negative 7 over 2. So this is an extra term that I'm adding. So I need to be consistent. If I'm going to do it to the left, then I need to do it to the right. right? So what is negative 7 times negative 7? 49. And 2 times 2 on the bottom is 4. So we're adding an extra 49 over 4 in here, in this parentheses, which means we also have to do it on the right hand side. Okay, and this is why it's very important to know how to work with fractions. I can rewrite, I need to add 12 and 49 over 4. Okay, I am going to go ahead and find a common denominator. So what's the common denominator of 1 and 4? 4. So I'm going to go ahead and use 4 as my common denominator. This guy's going to stay the same, and this one was changed, right? So what is 1 times 4? 4. So do 12 times 4, which is 48, right? So then let's go ahead and do the math. Okay, so that means that we got that y minus 7 over 2 squared is 97 over 4. Okay, are we done yet? Nope, not quite, but we're almost there. So this is y minus 7 over 2 squared equals 97 over 4. And this is the same as the square root question in letter G, which is, hey, what's the opposite of squaring? Square rooting. Okay. So now this is just gonna help us cancel out the power of 2. And don't forget, when you get the square root, you're getting a plus or minus answer. Right, so this is y minus 7 over 2 equals plus or minus the square root of 97 over the square root of 4. Remember that because these are both in square roots, now you can divide them, right? So unfortunately 97 is not divisible by 4, right? That would be a decimal. So instead what we can do is let's get the square root of the numerator and the square root of the denominator, see if there's anything that simplifies, and usually one of the numbers can simplify. Right, so the square root of 4 down here is 2, so I'm going to replace it with 2. Alright, so almost there, we just need our y alone. Opposite of subtracting 7 over 2 is adding 7 over 2, so it's going to be y equals 7 over 2 plus or minus the square root of 97 over 2. You can write it like this and split the 2's in the denominator, or just write it together with 1, 2, dividing both. In other words, you can write this like this, or you can write it as 7 plus or minus the square root of 97 all over 2. Right? Takes a while. You would get this answer if you did quadratic, right? As you can see, there's the b, the plus or minus, the square root, the number on the bottom. So, but this is a different method that is necessary and useful as well. Okay, letter K, solve for x using any method. Well, since it's already set up for us like this, you could do this, complete the square method, but since this number is 7, we're going to have a decimal again. We're going to have 7 over 2 as the number in the parentheses, and it gets kind of complicated because we also have a 2 up here. So let's just either do factoring or quadratic, okay? Solve for x, this is a quadratic function, so you could use any of the 3 methods. So I'm going to go ahead and add that 3, have it on the same side, and now I can do quadratic or factoring. Okay, I'm going to try to factor it first, and then now I'll do quadratic. I like to factor. So x squared we split as x and x, and then the factors of 2, 2 and 1. Okay, factors of 3, 3 and 1. Right, if that doesn't work, I could always swap the 1 and the 3, right? Or the 2 and this one, right? Again, you could do quadratic if you're not a huge fan of factoring. Okay, so because this is positive 3, I'm going to make these either both positive or both negative. I'm going to make them both positive because I'm trying to get to 7x. So check your outer and your inner, and make sure you get 7x. Okay, we did, which means we did factor this correctly. So now just set them both equal to 0 and solve for x. And this is why it's important to know how to solve linear equations. Okay, this means that x equals negative 1 over 2, right? When you subtract 1, divide by the 2. Or x equals negative 3 when you subtract 3 on both sides. Okay, so 2 are your answers. All right, next we have the midpoint formula, which is super easy. You're gonna find the middle point between two ordered pairs. Okay. So let's say you have the ordered pairs 5, 9 and 10, 17. Can you find the midpoint? Yes, you can. There's a formula for that, or you can just think about it logically, right? Just average the numbers the same way that you average your exams to see your current grade. Okay, so this is x1, y1. This is the first ordered pair, so we're gonna call it 1. So first number is always the x coordinate, second number is always the y coordinate. Let's call it 1, so we know that's part of the same ordered pair. And over here, x2, y2, to say that this is the second ordered pair, okay? So we're gonna go ahead and we're gonna average. Okay, so how do you average? Average is basically you add up the numbers and divide by how many there are. Right, so for the first coordinate, we're going to average 5 and 10 and divide by 2 because there's 2 of them. And then for the y coordinate, we'll add the 2 y coordinates and divide by 2. It's going to be 15 divided by 2, and 9 plus 17 is 26 divided by 2, right? So that means the ordered pair between these two ordered pairs is 7.5, 13, which you should know how to graph all these ordered pairs if you needed to on a number line, on a coordinate plane. Alrighty, letter M, distance formula, which is basically the Pythagorean theorem in disguise. Okay, same ordered pairs, but now we're going to find the distance between them, which technically means you could make it into a right triangle and then use the Pythagorean theorem, but this is essentially the same as the distance formula, just rearranged for you. So all you have to do is plug in correctly. Easy points, easy question. This is just 5 squared, which is 25, plus 8 squared, which is 64. Add it up. And what do you get? You get the square root of 89, and if you have the calculator, you can just write what that is as a decimal as well. But the square root of 89 is good enough. Okay, I won't go over the bonus question. I always like to put a bonus question. But this is just to derive the quadratic formula by completing the square. I have uploaded that in the notes, and we've gone over it. Pretty cool. Pretty cool. You basically just get a normal quadratic function, standard ax squared plus bx plus c, right? The general form. And you basically do complete the square, right? So subtract the c, divide by the a. Basically, you do complete the square, but instead of with numbers, you're doing it with a, b, and c representing numbers. And then if you do the steps correctly, you're going to end up getting the quadratic formula, which is really cool. All right, so let's go over letter N. Letter N is a circle, and you can tell it's a circle because it has 2 variables, x and y in it, which means that we're going to be able to complete the square. What do we do? First step of complete the square is get the number on the right hand side. So I'm going to add 47 to make that happen. Now thankfully I love it when these numbers are even, because that means when I divide by 2 I'm going to get whole numbers, which is always nice. So apply the steps for complete the square. So b is in front of the variable, right? So b is 6 divided by 2, which is 3. And that's what we're going to use to complete the square. Okay, but remember that if you were to expand this, if you FOIL it out, you're adding the extra L in FOIL, which is 3 times 3. What is 3 times 3? 9. So that extra 9 you're adding in here as part of the number squared. So you also have to add 9 on the right hand side. Okay, and then over here, same thing, I'm going to get b, which is -8, divided by 2, and use that as my complete the square, right? So that's y minus 4 squared that we're going to be using. This gets me my y squared back, my negative 8y squared, my negative 8y back, but it adds the extra and FOIL, which is negative 4 times negative 4. Okay, so that extra 16 that we're adding in there to make this happen, I need to also add the 16 on the right hand side. Okay, so now just add the numbers on the right hand side, and we'll be able to use the standard form of a circle to find the center and the radius. Okay, so on the side, just add. Okay, so that means that the center of this circle is negative 3 comma 4, right? The number that I'm subtracting from x. So this could be rewritten as x minus negative 3. So negative 3 is being subtracted from x, that's my h. And the 4 is being subtracted from y, so that's my k. So h comma k for center. And for radius, it is this number, the square root of this number, which again, you should know how to simplify, so you can do it yourself. Check your work. It should be 6 square root of 12. And that's as far, 6 square root of 2. That's as far as you can go. Okay. That means you have a couple of 2 and a couple of 3. They both come out on the outside, they get multiplied. And then there's an extra 2 that's just single and waiting for his time to come. So he's staying in the house, in the square root sign. Okay, now let's look at one of my favorite topics is radical equations. Okay, can you solve for x? Well, yeah, we could. So we have a square root and we're trying to get the x, right? So what do you do when you're trying to get x? Isolate x, and since the x is inside of the square root, we're gonna isolate the square root, okay? Which means you gotta cancel this 3. Okay, so this is the square root of 2x plus 2 equals x minus 3, okay? Now, what is the opposite of squaring? What is the opposite of the square root? To square, right? If I were to multiply the square root of 2x plus 2 with the square root of 2x plus 2, since you're multiplying the same square roots, the square roots would cancel and you're just left with the number in the inside. Okay, so same concept. So here I'm going to be left with just the inside of the square root. And of course what you do to one side, you do to the other, so you also have to square the right hand side. Okay, so this is where FOIL comes in. X minus 3 times x minus 3. FOIL it out. Okay, and then from there just solve for x. So at that point you should know how to get your like terms together, solve for x. So let me get my terms all on the same side. Okay, so that means I have to subtract 2x from both sides. Oops. And then subtract 2 from both sides. Oh, what do you know? This is a quadratic function. I can either factor or use the quadratic formula to solve for x. Okay, factors of 7, 1, and 7, my only options, right? Because it's positive, I'm gonna either have to make them both positive or both negative. I'm gonna make them both negative because I'm trying to get to negative 8x. So you check yourself when you do the outer and the inner. What is negative 7x minus 1x? Negative 8x, right? So we did it correctly, and now just solve for x. So this means that x equals 1 or x equals 7, right? So just solve. If 1 is in here or 7 is in there, then that would get the parentheses to equal 0, right? So you, at this point, you know how to solve a basic equation. So those are my two answers. Of course, you have to plug them in, because for these, with the whole way the square root works, well, it's possible that one of them may not work out. Okay, so once you plug it in, which you could plug it in yourself and check. Let's plug in 1. 1 times 2 is 2. 2 plus 2 is 4. The square root of 4 is 2, plus 3 is 5. I'm just plugging in. Does that equal 1? No, so 1 does not work. Remember, this is an OR statement, so it could either be 1 or it could be 7. We did all this work. Right, when you plug in 7, do the math. 7 times 2, 14, plus 2 is 16. Great. What's the square root of 16? 4. Does 4 plus 3 equal x, where x is 7? Yes, it does. So that means x equals 7 is my only solution. Right, this is always good practice to get your answers and then say, okay, is there anyone that I may have to throw out? Am I not allowed to have a negative? Maybe because it's like a log function and the domain is positive numbers, 0 to infinity. Maybe I can't get the ln of a negative number, it's invalid, or perhaps it's a square root and it doesn't work for me because of the way that square roots work, etc. So it's always good to double check and look at your answers. Okay, so then now we're on to the last question. Of course, there are a lot of topics to review, and at the end of the course, you should always feel better about all the topics covered because you've been using it more and more, right? With the second material, we used all the first material and then added onto it and graphed and so on. So it all kept on building on each other. You should feel good with it as long as you've put the work in, you've studied, done your homework, looked over the notes that you took, or some of the ones that I posted. I did post the majority of them. Okay, so let's solve for x. Okay, so this is a U substitution question, okay, and you should recognize it because this looks very close to a quadratic function, but it's not exactly a quadratic function. So what do I have to do? Let's see if we can let U or some variable equal something and then plug it in and solve, right? So I'm giving you guys a hint to try to use the inside term. What I mean by that is not the number, but the function that you see on the inside. So is it an x? Is it e to the x? In this case, it's x to the negative 1, which at this point, you guys know how to rewrite as a positive exponent, right? If you bring this x to the denominator, now it has a power of 1. So it's just 1 divided by x. Okay, cool. Now, question is there any way that I can rewrite x to the negative 2? Yes, x to the negative 2 is simply 1 over x squared, which is 2 of these, right? It's 1 over x times 1 over x, which is essentially u times another u, or u squared, right? You should be able to see that. We write this as a negative exponent as a positive exponent. See that there's 2 x's multiplied on the bottom, which means it's a u times another u, or u squared, right? At this point, we have a quadratic function. I can either factor or do a quadratic formula to solve for u. Keep doing this, so it's very good. And if you don't get something, it is your responsibility to make sure that you do get it. So whether it's Khan Academy, iExcel, YouTube, homework, textbook, you can always read the textbook, look at the practice problems on my math lab. They're all good ways to practice. Okay, so factors of 40, there are a lot of factors, but at this point you should be able to think about the exact factors that's going to help me get negative 3 when I subtract these factors, right? So if I use 8 and 5 and make one of them negative and one of them positive, then that means that I'm getting the negative 40 I need for last. And then check outer and inner. So outer numbers times inner numbers. Does that give me a negative 3u? Yes, it does. So that means that I did this correctly. So now all you have to do is solve for u. Okay, so that means that u equals negative 5 or u equals 8. Because remember that you're setting these equal to 0. So you're solving. So this means either u has to equal 8 or u has to equal negative 5. Okay, but remember this is not our final answer because we substituted for u. So now we have to substitute back in what it actually is. It actually is 1 over x, but we changed it to make it easier for us to solve. So the question is, we're super close. Is there any way we can get x? And the answer is, of course. We know algebra skills. We know how to cancel denominators. And so that's the last step, right? So how do you cancel a denominator of x? Multiply by x. Multiply by x. This is just 1 equals negative 5x, and then divide by negative 5, divide by negative 5. Okay, so this is one solution. And the other one, multiply by x, cancel, multiply by x. 1 equals 8x, so what does x equal? 1 over 8. Okay, you can leave it like that, or if you prefer to write it as decimals, you can as well. That would be 0.125 for the 1/8, or negative 0.20 for the negative 1 over 5. Okay, so that's it. Review your exams, exam 1, 2, 3, and make sure that you're ready for your final, if you're one of my students, or just use this and hopefully this helps you review important material that you're going to use not only in MAC 1105, but in your future courses and hopefully in your life, right? Critical thinking is always necessary. All right, so take care, and until next time.